Hello, my name is Victor Stoyanov, and this is my final project pseudocode presentation. The very first thing we must do, regardless of which matrix operation the user would like to do, is to declare and write out all of our functions for different matrix operations. Then, in our main function, we will ask the user to input which matrix operation they'd like to do. This will be stored as a character, which will be used to determine the type of function that will be done. If their input is A, the matrix operation that will be done is either addition or subtraction. If it is B, we will multiply the two matrices together. If their input is C, we will find the transpose of the matrix. If their input is D, we will find the simultaneous linear equation of a function with three unknown variables. If none of the above are typed, we will ask the user to go again and type in a valid matrix operation. If the user input is B, we will be multiplying two matrices together. First, we will initialize the values we will be using such that our first and second matrices, variables for the size of our matrices, values for our loops, and our resultant matrix. Once this is done, the user will be asked to enter the size of the first matrix. Once this is determined, we will ask the user to type in all of the elements of the first matrix dependent on its size. Using a for loop, each element will be added to its corresponding spot in the matrix. After this is done, the user will be asked to enter the size of the second matrix. We will follow all of the same steps as the first matrix to type in all the elements depending on its size, and to use a loop to add each element in its corresponding spot in the matrix. Next, we must check if the matrices can be multiplied together. If they aren't compatible, then we must tell the user that the columns of the first matrix aren't equal to that of the second matrix. This means that we will not be allowed to multiply the two matrices together. Otherwise, we will multiply the matrices together. This will be done by using three loops inside of each other. The first loop will go through each value dependent on the size of the rows of the first matrix. The second loop will go through each value dependent on the size of the columns of the second matrix. A third loop, dependent on the rows of the second matrix, will be used to multiply each value in the respective row or column and add it together to a resultant matrix in value I for columns and j for rows. This is also known as a dot product. Once this is done, we will print out our resultant matrix. If the user input is D, we will find the solutions of simultaneous linear equations with three unknown variables x, y, and z. First, we will create a function that will be used to calculate the determinant of a matrix. Based on the formula for finding the determinant, it will return a value. In our main function, we will initialize our values such as our first and second matrices, values for our loops, and our results for x, y, and z. The user will be asked to enter the element of the first matrix, which is a 3x3 matrix. These are the three equations with unknown variables. Using a for loop, each element will be added into its corresponding spot in the matrix. The user will then be asked to enter the elements of the second matrix, which is a 1x3. These are the solutions to the three equations with unknown variables. Using a for loop, each element will be added into its corresponding spot in the matrix. To determine the unknown x value, we will find the determinant of a matrix with columns of the solution matrix, the y variables, and the z variables. To determine the unknown y value, we will find the determinant of a matrix with columns of the x variable, the solutions matrix, and the z variables. To determine the unknown z value, we will find the determinant of a matrix with columns of the z variables, the y variables, and the solutions matrix. This is also known as Cramer's rule. Once this is done, we will print out our results for x, y, and z. Thanks for watching.